Hi friends, in this video we're going to talk about proportions. So what does it mean for something to be proportional or disproportionate, and then how to solve, kind of like an equation, solve an equation so that two ratios are proportional. So a proportion is an equation stating that two ratios are equivalent. Okay, and so you can do it by multiplying as fractions, or you can do cross products, and we'll talk about the three ways. So if we have 2 to 3 and 4 to 6, if I can multiply both sides of the ratio by the same number and produce the other ratio, they are equivalent and proportional. Okay, so I'm going to start on the left. I'm going to say, how do I go from 2 to 4 by multiplying? Well, that's times 2. 2 times 2 is 4. That side is equivalent, and I have to use the same number. So I'm going to say, is 3 times 2 6? Yes, 3 times 2 is 6, so they are proportional. I can also do them as fractions. Okay, so if I can multiply this fraction by the same amount and you get the other one, so from numerator to numerator, how about we do them side to side? It's a little easier to see if they're side to side. So from 2 to 4, I'm multiplying by 2, and from 3 to 6, I'm also multiplying by 2. So that means they are proportional. Okay, so if I multiply by the same number or divide and get the other one, they're proportional. I can also do something called cross products. You might have heard it called the butterfly method. Okay, that's where I go across diagonally and I do 2 times 6. I want to know, does that equal 3 times 4? 2 times 6 is 12, and 3 times 4 is also 12. Okay, so 12 is equal to itself. So if I cross multiply and the products are equal, then the ratios are proportional. Okay, so it's just ratios that are equivalent. I can either set them up like over here, and I saw, oh, I can multiply, or I can multiply straight across, or I can cross multiply. So let's try this example. Let's try another one. Okay, we're going to do it just by multiplying here. So I have the ratios 5 to 12 and 15 to 48. Okay, and I know that 5 times 3 gives me 15, but 12 times 3 is 36, which is not 48. So if I multiply both sides of the ratio by the same number, and it doesn't produce the other ratio, so if I had multiplied this one by 3, oops, there we go. If I had multiplied it by 3 on both sides, it would have given me 15 to 36, which is not the same as that one, which means they are not proportional. Same thing with the fraction method. I'm going to reduce the fractions. So I'm going to have 5 over 12 and 15 over 48. Well, 5/12 is the smallest it's going to get because 5 and 12 don't share anything in common. 15 and 48 can both be divided by 3, which is going to give me 5/16. Okay, and 5/12 does not equal 5/16. So if I can reduce one fraction by a number and it doesn't produce other fractions, they are not proportional. Okay. Keeping them as fractions. I'm going to cross multiply. I'm going to do 5 times 48. I want to know, does that equal 12 times 15? Okay, 5 times 48 is 240. Does that equal 12 times 15? Which is 180. Those are not equal. So if I cross multiply and the products are not equal, the ratios are not proportional. Okay, so solving proportions. Sometimes we have a proportion and there's a missing part and we want to know what that part is. And so the easiest way to do it, I think, is to use cross products, or the butterfly method, or also called cross multiplication. So, solve for x. See, x is here is the part we don't know, such that the two fractions form a proportion. So we're going to find the quotient between 8 and 24. So I'm just going to take 24, the bigger one, and divide by 8, which is 3. So I can see that going from 8 to 24, I'm multiplying by 3. So I'm going to take that 3 and multiply it by the other numerator right here, 3. So to go from 3 to x, I have to do the same. What I'm doing on the bottom, I have to do on the top and multiply by 3, which gives me 9. So x equals 9. And then to check my work, I'm just going to take that fraction, 9 over 24, and simplify it to double check that it produces an equivalent fraction. So I'm going to divide by 3, gives me 3 over 8. And that worked, so x is my solution. Okay, and sometimes you might have a proportion in the form of ratios with a colon in non-fraction form. So the first thing we have to do is I want to find the value of a so that the ratio 2 to 3 is proportional with the ratio a to 5, or a to 15, sorry. So I'm going to write them in fraction form. 2 to 3. I know they're equal because I'm making them proportional. Okay, so before we didn't know whether or not they are equal, but now we do know that because that's how we're setting it up. Then I'm going to cross multiply. 2 times 15 is equal to 3 times a. Okay, 3 times a is 3a, and 2 times 15 is 30. Now I'm just going to solve for x. I'm going to divide by, or a in this case, solve for the variable. Divide by 3, so I'm left with 1a equals 30 divided by 3 is 10. So that's what I think my answer is. I'm going to check my work. I'm going to take 10 over 15 because my a value was 10. That's what I think it is, what I found it to be, and my other value is 15. I can divide both of these by 5, gives me 2 over 3, which was the same as that other fraction, so I know that I am correct. Hope this was helpful. Just a quick refresher on what ratios are, what proportions are, sorry. How do I know if ratios are proportional, and then how do I solve for that missing part in the proportion? As always, let me know if you have any questions, and have a great day, guys.